Hello, and welcome back to Cinderella Math. This is for pre-calc slash if you are in like a college level trig. This could be helpful for you too. Maybe if you're in advanced algebra 2, kind of just depends, but mostly here probably targeting my pre-calc people. This particular paper that I'm about to do was sent to me by a student, but it has her name on it, so I don't want to project that, for her privacy. So I will be writing the questions, and they are kind of split into a couple categories here. Before you begin, or, grab pencil, paper, you probably will not need a calculator. I mean, you're welcome to have one, but I don't think you'll need it. Pencil, paper, and you will want with you a cheat sheet for trig identities. Either your teacher or your professor should have given you one. If not, just go on Google real fast and type in trig cheat sheet. You'll find a multitude. I have found this one here from Paul's Math. He's a really good online resource. Um, but any trig cheat sheet with identities is what you need. You can either leave that up on your computer or phone, or probably even better, just print it out and have it beside you so you can just reference it. Usually we do not memorize these, especially the more complicated ones. Usually we just refer to a cheat sheet, or a reference sheet, if you will. So I will be toggling to this reference sheet. So have one of those either with you digitally or print it out as we work these problems. Some of these do come up so often that we will just memorize it, but other ones will just always come back to our sheet. Alrighty. So I will be referencing the numbers on my tutoring students um, worksheet, and I will tell you the directions as well. I have been having some issues with this like writing pad that I use. If my pen skips a little bit, I'm sorry. I've been trying to fix it. We'll see how it goes today. So this is section 1. It has 4 problems. See if the pen will come to life today. Maybe, maybe not. Oh, okay, here we go. Come on, pen. There we go. My pen's alive. All right, it has 4 problems, and the directions say factor the expression and use fundamental identities to simplify. All right, so directions, factor, then simplify. All right, here is number 1. Cotangent squared of x minus cotangent squared of x cosine squared of x. Well, this clue in the direction is very nice. It does say to factor. So on this one, I do see a greatest common factor, or GCF. This guy has cotan square. This one has cotan square. So we are going to pull that out, pulling out the GCF of cotan squared of x. So basically you're doing cotan square, divide cotan square, so that would be 1. Keep the minus, and then if you divide this one by cotan square, you'd be left with cosine squared. Okay, so there was the factoring, so check, and now simplify. There is a rule, and if you go to your cheat sheet, you will see it. I'm just going to write it to the side here. It's a very good one to memorize because it comes up all the time. If your cheat sheet is broken down into categories, this would be under the Pythagorean identities. And it says sine square of an angle plus cos square of an angle is 1. That could be switched around. It could be cos square plus sine square. It doesn't matter. And you might be like, well, that's not what we have. No, it's not. Look at our parentheses. We have 1 minus cos squared. So what if we just move that over? We would have sine square is 1 minus cos square. So this 1 minus cos square in our problem can be replaced with sine square. So we're making this replacement using this fact off to the side, which comes from the Pythagorean identity on your cheat sheet. So this is now sine square And then it's still times cotangent square. All right, again, this comes up so often you may want to memorize this one. If not, you'll come to your cheat sheet and it'll be under the quotient identities. And it will say cotan of some angle is cos over sine. So we are going to make that substitution. We don't have cotan though, we have cotan squared. That's okay. Just make them both squared. So this will be cos squared over sine squared. And then we're still timesing sine squared. And then lastly, these can cross cancel, giving us a final answer on this one of cosine squared of x. We factored out a GCF and then we used a couple different identities to simplify. Okay, I'm going to be moving pretty fast. Pause me if you need to. This is number 2, same directions. Factor, then simplify. We have sine squared of x, secant squared x, minus sine squared x. So again, I see a GCF. He has a sine square, he has a sine squared. Let's pull that out. GCF, greatest common factor, is sine squared. What would be left? So basically you're dividing this by sine square. So he's gone. So you still have secant squared. And then you're dividing this by sine square. So that's gone. So that's just invisible 1 there. Okay, so we have pulled the GCF and now we just need to simplify. So again, you would come to your cheat sheet, and I will actually come to it now, and see if we can find something that will help us. Particularly looking for that secant square minus 1. So I'm coming over to my cheat sheet, except I've got it covered up. Let me clear this off. We're looking for secant square minus 1. Let's come to our Pythagorean, and this one. The middle one on my screen, trying to get the pen to work here. Come on, buddy. Right here. Tan square plus 1 is secant square. And again, that's not exactly what we have, but we're going to manipulate it. Okay, so off to the side here, the Pythagorean identity that's going to help us this time is tan squared plus 1, tan square of an angle, sorry, is secant squared. That's not exactly what we have, but if we just move that 1 over, we would have tan squared is secant squared minus 1. That is what we have, underlining in blue here. We can make that substitution using that Pythagorean identity to help us. So we are going to change secant squared minus 1 into tan squared. And then we still have sine squared. Again, this next one comes up so often. If you can memorize it, that's great. If not, you would come back to your cheat sheet, back to the quotient identity. Tan of an angle is sine over cos. Well, we don't have tan, we have tan squared. That's okay, just square both of them. So that's going to be sine square over cos square times sine square. Ooh. Okay. So that would be sine to the 4th over cos squared. I'm just seeing if I missed anything. That could be fine. I don't have an answer key on this, so let me just make sure it looks fine. Yeah, I don't know if that's any better than just leaving it at the blue. I think this might be fine. However, some teachers want you to have it completely in sine and cosine. So if so, you could probably go with this one. Or some teachers may not want you to have a denominator. So if you look at your reciprocal identities, 1 over cos is secant. So we might take this green one and keep the sign to the fourth, and then this would flip up. The reciprocal would be secant squared. That could be an answer too. That's the tricky part on these. Sometimes there's multiple answers. I'm gonna make a note to look at that one again later. Just feels a little weird, but I don't see a mistake. So there we go. Let me just make a note. All right. Let me go to number 3. Same directions. This one's a little different though. I'm just gonna go up on top of the cheat sheet. This is number 3. We have tan to the fourth of x plus 2 tan squared of x plus 1. So this looks like a trinomial, right? It has 3 pieces. 1, 2, 3. Let's try to factor it. I factor with the magic X. If you factor it differently, that's fine. You do whatever you prefer for factoring. There's an invisible 1 here in the leading spot. I do the first number times the back number. So 1 times 1 is 1, and the middle number is 2. What multiplies here adds to here? Well, that'd be 1 times 1. So if we factor this, it would be plus 1, and then to know what goes in the front, by the way, that came from right here. These were both positive 1s. Then to see what goes into the front, you take this front guy and cut it in half. So that was tangent to the fourth, cut it in half. So that would be tangent squared and another tangent squared. Okay, we could also write this as tangent squared plus 1 squared, right? Because they're the same thing. Either way is fine. And now again, you would come back over to your cheat sheet, and under that Pythagorean identity, if I could spell, that would be great. We should have that tangent squared plus 1 is secant squared. So this that I'm underlining can be replaced with secant squared, and then that's still squared. Remembering from algebra that a power to a power, we really multiply. So the final answer is going to be secant to the fourth of x. Okay, that one came out very nice. I like that. And then we did factor. That one was not a GCF factoring. That was a trinomial factoring. And we have one more under this category of factoring. This is number 4. And it is, sine to the fourth minus cos to the fourth. So there is no GCF. There is not a trinomial to do that magic X thing. This is a difference of square. That should ring a bell from algebra. If it doesn't, real fast, just pretend for a second that we had a square minus 16. You split that into 2 pieces. You take the square root, which would be a and a. You take the square root, which would be 4 and 4. You give 1 a plus, 1 a minus. That's difference of squares. So that is what we have here. So we're going to set up our 2 parentheses. We're going to take the square root. So the square root of sine to the fourth, you just cut that in half. That'd be sine squared in both of these. Take the square root. So again, just cut that in half. That would be cos squared in both of these. 1 plus 1 minus. Well, hold on a second. Come over to your Pythagorean identities, and this is the one you want to memorize if possible. Sine square plus cos square is 1. So this first parenthesis with the plus on my screen is 1. And then this guy is another difference of squares. I don't know if we really need to do the difference of squares. Hmm. Okay, so you could, who cares about a one, right? Don't even write that. You could probably just leave it as sine square minus cos square. I would probably take that answer. Or you notice that that's a difference of square again. So we'll do two parentheses. We'll take the square root, which would just be sine in both. And we'll take the square root, which would just be cos in both. 1 plus, 1 minus. So I think I would take the green answer or the blue. Probably the blue is broken down more. So if it's like the directions were like simplified completely, probably the blue is what they want. But yeah, they're technically the same. There are no identities that look like this. You can look on your paper. There's none that are just sine plus cosine or sine minus cosine. So that's the best we can do. All right, that was the end of this little section that said factor, then simplify. We have two questions in our next section, and I'll type out the directions here. The directions for this are perform the multiplication, so multiply, then use identities to simplify. So multiply, then simplify. And there's only two in this category here. Here's our first one. This is number 5. Number 5. It is parenthesis sine plus cosine squared. Sine x plus cos x squared. So you know square means do it twice. So let's write this twice. Sine x plus cos x, and then do it again. Sine x plus cos x. And now multiply that out. You might call this FOIL, you might call it rainbow, whatever you call it, multiply. Sine times sine would be sine squared. Sine times cosine would be sine cosine. Under would be another sine cosine. Yes, you could put cosine sine, but it's fine. And under again would be cosine squared. These two in the middle are like terms. There's an invisible one, there's an invisible one. Add that together and we'd have 2. Sine x cos x. And then we still just have cos squared at the back, sine square at the front. But this is adding. With adding, we're allowed to change the order. So I'm going to change the order to be sine square plus cos square plus 2 sine cos. And then, oh, there he is again. Pythagorean identity. Sine square plus cos square is 1. So this right here is 1 plus 2 sine x cos x. Answer. Or the order could be switched. It does not matter. You could do 2 sine x cos x and then add the 1. Either way, it's right. All right. Let me see something real fast here. I feel like that might be one of the double identities, but I don't think it says on the worksheet to use fundamental identities, and I don't think that would be considered a fundamental. So I think I'm just looking just for my own curiosity here. Where are the doubles? There they are. Okay, so if you see this very first double one right here, we had that in our answer, didn't we? Didn't we have 2 sine x cos x? So what I had was right, and I think this is right using fundamental identities. If you already know the double identities, or if your teacher expects you to be using the double identities, 2 sine x cos x is sine of 2x. So the red there is correct using fundamental identities. If you're expected to use double identities, also correct would be 1 plus sine of 2x. And again, you may not be needing that second answer, that green answer, but maybe you are. I don't know. All right, there's one more under this header of multiply, then simplify. This will be number 6. It is parenthesis secant x plus 1, new parenthesis secant x minus 1. All right, let's multiply that out. So secant times secant would be secant squared. Secant times -1 would be negative secant. Under positive 1 times secant would be positive secant. And 1 times -1 would be -1. Combining like terms, negative secant plus secant. Well, this just cancels. Bye-bye. And we are left with secant squared minus 1. Come back to your cheat sheet. Under the Pythagorean, we have one that says tangent squared plus 1 is secant squared. But that's not what we have. But if we just move the 1 over, we would have tangent squared equals secant squared minus 1. That is what we have. So we can replace that final answer, tangent squared. Okay. Those are the only two under the heading of multiply, then simplify. I now have two under the heading that says perform the addition or subtraction, and then simplify. So these are going to be a little bit more annoying because we're going to need a common denominator. This is number 7. And again, the directions are add, subtract, then simplify. I have 1 over 1 plus cos plus 1 over 1 minus cos. All right, we can't do anything with that until we get a common denominator. So over here, we need to invite 1 minus cos. Be fair and invite it upstairs. And on the right side, we need to invite 1 plus cos. Be fair and invite it upstairs. All right, so on the top, we would just have 1 minus cos plus 1 plus cos. And on the bottom, we have a big fraction with a common denominator of 1 minus cos, 1 plus cos. Okay, on the top, combining like terms, 1 plus 1 makes 2. And then negative cosine plus cosine would cancel out. Negative cos plus cos, bye-bye. And on the bottom, if we FOIL that out, or multiply, that would be 1 plus cos minus cos minus cos squared. Okay, in the middle, cos minus cos is gone. So that leaves us at 2 over 1 minus cos squared. Back to the Pythagorean identity that says sine square plus cos square is 1. That's not what we have, but if we move this over, we would have sine square equals 1 minus cos square. Now that is what we have. We have 1 minus cos square in our denominator, so we can make a substitution. We still have 2, we still have fraction, but we can replace 1 minus cos square with sine squared. And then usually we just don't like to keep a fraction. So again, back to your cheat sheet, or you might just know this, you're going to come under the reciprocal category. I'm in the orange pen here. And it should say 1 over sine is actually cosecant. So we're going to flip this up. We're going to keep the 2. And the sign on the bottom is really cosecant. And we had sine square, so we're going to make that cosecant square. Answer. That was number 7. I'm sorry for the pen. It's halfway working, halfway not. Oh, so frustrating. Okay, number 8, same directions, add or subtract, then simplify. So that last one was an adding. So my money on this one would probably be that it's a subtracting. Nope, it's an adding again. All right, so this is cos over 1 plus sine plus 1 plus sine over cos. So again, there's nothing we can do with this as it sits. We need a common denominator. We're going to invite cos to the left, upstairs to be fair. We're going to invite 1 plus sine to the right, upstairs to be fair. Okay. All right, so on the top, cos times cos would be cos squared plus, and then we'll need to FOIL or rainbow or just multiply this other top. 1 times 1 is 1. 1 times sine, sine. Under would be another sine. And under sine times sine would be sine squared. And then the bottom would just be cos times 1 plus sine x. And it's all just one big fraction now because we got a common denominator. So yay. Just looking at the top, cos squared plus sine squared. And again, if you want to rearrange that so that they're together, that's fine. But it's allowed, right? I'm just going to put this on the other side. We can just move it, and we're allowed to do that because with adding, you can do it in any order. So I've just moved that sine squared over to the front, and now sine squared plus cosine squared, I've written it like 7 times now, that is 1. That is the Pythagorean identity. So this guy is going to scratch out and just be 1. So now on the top, we have 1 plus 1, so 2. And then we have sine plus sine. Well, this one has an invisible 1. This one has an invisible 1. So 1 plus 1 would make 2 sine. And on the bottom, I would not distribute the bottom. Let's just leave it as cos x times 1 plus sine x. Okay, that's a parenthesis. This pen is not working. On the top, this has a 2, this has a 2. So let's factor GCF a 2. So divide by 2, which will leave 1. Keep the plus. Divide by 2, so this would cancel and leave sine. And on the bottom, we would still have cos 1 plus sine. Oh my gosh, this pen's gonna kill me. Okay. Something good happens here. 1 plus sine, 1 plus sine. Bye-bye. Bye-bye. And we are left with 2 over cos. But then again, if you can get it to not be a fraction, that's typically preferred. So you're going to come to your cheat sheet, or you might just know you're going to come to your reciprocals. And if it's 1 over cos, or basically the flip of cos, you know that is secant. So coming back to our problem, we're basically going to just flip this cos up, and that's going to give us a final result of 2 secant of x. Answer. And that was number 8. All right, if you're my actual student who sent me this paper, there is a back where you're supposed to, like, they give you the answer and you need to, what's the directions? It says verify the identity. I was going to do that right now, but the pen is giving me fits, so I'm going to try to restart my computer. So that'll just be a separate video of verifying. So this one was just simplifying identities. I think that's how I'll label it, simplifying identities. I hope this was helpful, whether you're my student that I private tutor or not. I hope that was helpful. Sorry for the poor handwriting because of my pen. Hope you're having a great day, and bye-bye.